Welcome back. Today, we're diving into Spring JdbcTemplate and learning how to perform insert operations, step by step. Let's get practical with database operations. I tried my best to keep this video short, but there's just so much to cover. So, stick with me till the end, and by the time we're done, you'll know exactly how to insert data into the database using Spring JdbcTemplate the right way. Alright everyone, today we're taking a big step forward. It's time to implement our addEmployee method. Remember how we used to store our employee data in a simple map and manually generate the employee ID? Well, that's in the past. Now, we're moving to a proper database where all the data gets stored persistently, and the database itself handles generating a unique employee ID for each new record automatically. This means less manual work for us and a more robust solution overall. Let's jump into the code and see how we can insert an employee into the database using Spring JdbcTemplate. Here we go, follow along on my screen. Alright, let's start coding. Now create a new interface named Employee Repository within our DAO module, specifically within the repository package. Alright, now let's add the method saveEmployee to our Employee Repository interface. This method will save an employee's data into the database. It takes an employee object as input and returns the updated employee object, so that, for instance, we can get the auto-generated ID once the record is saved. Create a new class named Employee JdBC Repository. This will be responsible for interacting with the database using JdbcTemplate. This class will be our JdbcTemplate implementation. Alright. We shall now annotate this class with @repository. This designates the class as a data access component. This annotation marks the class as a data access object, DAO, indicating to Spring that this is a repository layer responsible for database operations. This defines the class's role within the data access layer. Furthermore, it activates Spring's exception translation mechanism, which automatically transforms database-related exceptions into Spring-specific exceptions, such as data access exception, thereby abstracting exception handling. Now, let's implement Employee Repository. Alright, before we write the code for saveEmployee, we need a way to talk to our database. We're going to use Spring's JdbcTemplate for that. So, let's add JdbcTemplate to our repository class. Okay, as you can see, we're not getting the JdbcTemplate class here. That's because we haven't added the necessary dependency for it. So, let's fix that. We'll open our DAO module's pom.xml file and add the correct dependency. Previously, we had Spring Boot Starter added, but now we're replacing it with Spring Boot Starter JdBC. The reason? This dependency includes everything from Spring Boot Starter plus the required JdBC libraries for database interaction. Alright. Now that we've added the dependency, let's go back and try to import JdbcTemplate again. Oh. We're still not getting the JdbcTemplate class? No worries. This can happen sometimes when the project dependencies don't sync properly. Let's refresh our project to make sure the new dependency is loaded correctly. Still not working? No worries. Sometimes IntelliJ doesn't pick up dependencies immediately. If this happens, you can try restarting IntelliJ. Okay, now I'll type JdbcTemplate manually and try to import. Alright, it's working now. The required jar was already present, but IntelliJ was causing the issue. Let's use constructor injection to inject JdbcTemplate. Alright, now let's implement the saveEmployee method. Since we are inserting data into the database, we need to write a SQL statement, just like we would with a prepared statement. Because with JdbcTemplate we are going to pass the same query, but here connection open, close, and other stuff get hidden. JdbcTemplate handles the low-level database operations for us. As you can see on my screen, the first column is employee ID, but we don't need to insert it manually because it's auto-generated by the database. So, we'll skip that in our query. Next, we have employee name, so we include that. Then comes age, followed by joining date, and then department. We have created date, but we already set it to automatically insert the current timestamp in the database, so no need to pass it explicitly. Lastly, we have modified date, which we also configured to update automatically whenever the row is updated. Alright. Now, we'll call the update method of JdbcTemplate. This method allows us to execute our insert query. Here you see multiple update methods with different parameters. For now, we are going to use the one which accepts a query and object arguments. This allows us to pass our SQL and data in a structured way. As you can see in our query, we've used question marks as placeholders for values. These placeholders must be replaced with actual values in the exact same order as the columns in our query. That's because JdbcTemplate.update takes an array of arguments in that order. If the order is wrong, the data won't map correctly, and we might get SQL errors. So here, we're calling JdbcTemplate.update, passing our query as the first argument, followed by the values in the correct order. One more thing. If you pass values in the wrong order, your query might not fail, but your data will be incorrect in the database. So, always double-check the order of columns and values. The update method of JdbcTemplate returns the number of rows affected, just like a prepared statement in plain JdBC. So, we'll capture this return value and log it to check how many rows were inserted. Alright. Now that we've completed our repository implementation, let's move to the employee service impl class. Here, we need to inject our employee repository and entity DTO mapper. Let's do that just like I'm showing on my screen. Entity DTO mapper is a generic interface, so when injecting it, we specify that it's for employee and employee DTO. This helps us map between these two objects easily. Notice that I'm using constructor injection, which is the recommended approach in Spring Boot. This ensures that both employee repository and entity DTO mapper are available when this service is created. Alright. Now, let's store these injected dependencies in variables so we can use them later. Alright. Now, let's update our addEmployee method. As you can see on my screen, we were previously using a simple variable to generate employee ID and storing employee DTO in a map. But now, we're going to store data in the database using our employee repository. Oops. I forgot to return the employee object from the saveEmployee method in employee repository. For now, return the same employee object as the request without updating it. We'll implement the update logic later. Okay, let's change the code inside our addEmployee method now. So first, we convert our employee DTO to employee using employeeMapper.toEntity. This ensures our repository receives the correct entity format. Next, we call employeeRepository.saveEmployee, which stores the data in the database and returns the newly saved employee object. Since our repository is already returning the updated employee object, we simply pass it through our employee mapper to DTO and return it. Alright. Right now, our joining date is stored as a date in the database, and we also want to ensure that the response contains only the date, without any extra time details. To achieve this, we need to make a small change. I've added the @JSON format annotation with the pattern YYYYMMDD. This ensures that when we send the response, only the date is returned, without any unnecessary time details. Alright. We've made our changes. Now, it's time to start the application and see everything in action. Our application is up and running. Now, let's switch to Postman and test our API by adding a new employee. As you can see, I am adding a new employee named Alice, who is 22 years old. I have also provided a joining date and set the department to developer. Alright. As you can see, we got a successful response, which means our user is successfully added to the database. But wait. If you notice, the employee ID returned in the response is 0. Our API should return the actual employee ID generated by the database. We'll fix this later in this video, so stay tuned. Now, let's open dbeaver and check if Alice's data is actually stored in the database. Alright. Now, let's run a select query on the employee table to verify if our data is correctly inserted. Here's our newly inserted employee record. As you can see, Alice's details are successfully stored in the database. Also, notice the created date and modified date fields. Even though we didn't insert them manually in our query, the database automatically assigned values when the record was inserted. That's because we set default current_timestamp in our table schema. Now, look at the employee ID column. This value was automatically generated by the database, thanks to the auto_increment feature. Alright, our API is still returning employee ID 0. But don't worry, we'll fix that next. Alright. As you can see in the logs, we've printed the inserted row count. Since it's returning 1, that means our employee was successfully inserted into the database. Let's test by adding another user. This time, I'll add Bob, who is 23 years old and developer department. Alright. As you can see, we got a successful response, which means our user is successfully added to the database again. Alright. Now let's check our database to verify if Bob's details have been inserted successfully. Here it is, Bob's details are now present in the database. The employee ID is auto-generated, just like we expected. And as you can see, the employee ID for Bob is 2. Also, check out the created date and modified date columns. Just like before, we didn't insert these values manually, but the database automatically set them for us. Now, let's fix our API so that it correctly returns the generated employee ID instead of 0. Alright. Now, to get the auto-generated employee ID, we'll use something called a key holder. A key holder helps us capture the generated primary key when we insert a new row in the database. So, first, let's create an object of generated key holder and assign it to a variable. Generated key holder is a class that holds the keys generated by the database for auto-increment columns. Now, look at my screen. JdbcTemplate provides another update method, which takes 2 parameters. A prepared statement creator. This is a functional interface that we will implement using a lambda expression. And a key holder. This will store the generated employee ID. The first parameter of the update method is a lambda function. The request variable here is a connection object, which we'll use to create our prepared statement. Now, as the second parameter, we pass our key holder object. This will store the generated key when the insert operation completes. So, inside this lambda function, we use the connection object to prepare our statement, just like we did before. Now, let's set all the values using the set methods. First, for employee name, we use prepared statement.setString, one employee to get employee name. Since age is an integer, we use setInt, 2 employee.getAge. For joining date, since it's a date type, we call setDate, 3 employee.getJoiningDate. Next, we set the department value as a string, so we use setString, 4 employee.getDepartment. So, we simply return prepared statement, which will be used by the JdBc template to execute the query and insert the record into the database. Alright. Now, we need to fetch the employee ID that was generated by the database and set it in our employee object. We'll use the keyHolder.getKey.longValue method to retrieve the generated key. Since our employee ID is of type long, we need to call longValue explicitly. This ensures that when we return the object, it contains the correct database-generated ID. Great! Let's restart our application and test whether the API now returns the correct employee ID. Alright. Now, let's add a new employee, John, who is 34 years old and belongs to the HR department. Let's hit send. Oh. We got an exception, generated key not requested. Oops. I forgot to tell the database that we need the auto-generated key. Without that, it won't return the employee ID after insertion. To fix this, we need to explicitly request the generated key when preparing our statement. Let's pass an array containing the column name that holds the generated key, which in our case is employee_ID. Now, let's restart the application. Alright. Now that we've fixed the issue, let's try adding the same user again, John, age 34 from HR. See on my screen? This time, we got employee ID, 4 in the response. That means our database successfully generated this ID for John. Now, let's test one more time. Let's add another employee, Rock. Another success response. And as you can see, the employee ID returned is 5. Now, let's switch to dbeaver to verify. As you can see on my screen, Rock's employee ID is 5, and John's employee ID is 4. This means our auto-generated IDs are working correctly. But wait, John's record is inserted twice. Why did this happen? The first time we made the API call, we got an error, yet the record was still saved in the database. This happened because we did not disable autocommit in our JdBc operation. So even though an error occurred, the database still committed the transaction. To avoid such issues, we need to handle transactions properly so that if an error occurs, the entire operation rolls back instead of partially committing. Don't worry, we'll dive deeper into this in a future video. Stay tuned. Alright. Let's quickly summarize what we did today. We implemented the SaveEmployee method using JdbcTemplate and stored employee data in the database. We handled auto-generated employee ID using keyHolder. We saw how created date and modified date were automatically managed by the database. We learned that without proper transaction management, errors can still commit data to the database. In the next video, we'll implement our API to fetch an employee by their employee ID. So stay tuned. If you found this helpful, don't forget to hit subscribe, like the video, and drop a comment below. See you in the next one.